Hello guys, welcome back once again. This is question number 12. Okay, if you're just joining us, I've solved the remaining questions and they are on my YouTube channel. You can see there. So when you get there, remember to subscribe, remember to like the video, and if you have any question, you can ask your question. Okay, now question number 12. A constant voltage source in the circuit below supplies a sinusoidal alternating EMF. The voltages marked against the component are the peak values. From the diagram, look at it. Across the resistor, I have a 3 volt. Across the capacitor, I have a 2 volt. Across my inductor, I have a 6 volt. Okay, now determine the peak value of the applied EMF. We are asked to determine the peak value of the applied EMF. Okay, now there are key things you need to recall concerning an AC circuit, because the circuit given there is an AC circuit. Okay, and we are asked to calculate the total voltage. Now from the circuit, the voltage across the resistor in the circuit VR is given as 3 volts. The voltage across the capacitor VC is given as 2 volt. The voltage across the inductor VL is given as 6 volt. Okay, and we are asked to calculate the total EMF. Okay, now in an AC series circuit, the voltages across the resistor, across the capacitor, and across the inductor are not added directly like the DC circuit. You know that if it is a DC circuit, you just add the voltages together. Okay, that would give you our total voltage, which is the peak value EMF. Okay, now for us to find the total EMF, we first of all need to find the net voltage across the inductor and the capacitor, because they are 180 degrees out of phase. So to find the voltage across my inductor and my capacitor, which I'm going to have VLC, is going to be the difference VL minus VC. Okay, so what I'm going to have there is what? 6 volt minus 2 volts. So the difference is 4 volts. Okay, now by using the vector addition due to phase differences, the total voltage in an RLC circuit is found using this formula: V square equal to my VR square plus the difference now, that is VLC squared. Okay, now this is the relationship I'm going to use. Okay, so what I'm going to have is my V square equal to my VR is given as 3 square plus I've calculated the differences, right, which is my 4. So what I have is 4 square. Okay, so my V square is equal to 9 plus 16. All right, So 9 plus 16, I'm going to have v squared 25, right? So for me to find my v, I am going to square root both sides. Okay, so I have v square root equal to 25 root. Okay, square will cancel root, so my v is equal to 5 volts. Okay, this is my answer. Okay, this is my peak value of the applied EMF, and when you check from the question is option V. Okay, thank you. Please don't forget to check back for other questions. All right.